Constructing bored piles, also known as drilled shafts, involves creating deep foundations for structures where the ground is excavated before concrete is poured. Bored piles are commonly used in building foundations, bridges, and other heavy structures where high load-bearing capacity is required. Here's a step-by-step guide to constructing bored piles. 1. Site investigation and planning. Conduct a geotechnical investigation to understand the soil conditions, groundwater levels, and load-bearing capacity of the site. Design the pile based on the expected loads, soil properties, and depth required for adequate foundation support. Determine the diameter and depth of the pile. Typical diameters range from 0.6 to 2.5 meters, and depths can go up to 60 meters or more, depending on the project. 2. Setting out and positioning. Mark the exact locations of the piles on the ground using survey tools like theodolites and GPS, ensuring proper alignment and spacing according to the design. Install guide collars or casings to ensure the bore remains in position and the excavation is accurately centered. 3. Drilling the borehole. Use a rotary drilling rig or auger to drill into the ground to the required depth. The rig consists of a rotating drill bit attached to a drilling rod, which excavates the soil. There are 2 main methods for drilling. Dry method, used in cohesive soils, e.g., clay, where the borehole remains stable without support. Wet method, used when groundwater or unstable soil conditions are present. Drilling fluids such as bentonite or polymer slurry are used to stabilize the borehole walls. The rig continues drilling until the desired depth or the bearing stratum, rock or hard soil, is reached. 4. Temporary casing or slurry. In loose or waterlogged soils, install temporary casing or use drilling slurry to maintain the integrity of the borehole. Casing, a steel tube inserted into the borehole to prevent collapse during excavation. Slurry, a mixture, e.g., bentonite, that creates a pressure balance, preventing soil from collapsing into the borehole and supporting the sides until concrete is poured. 5. Cleaning the borehole. Once the drilling reaches the required depth, remove loose material from the bottom of the borehole to ensure a clean surface for concrete placement. Use airlifting or a clean-out bucket to remove sediment, soil, and water from the base of the bore. 6. Reinforcement cage installation. A reinforcement cage, made of steel rebar, is lowered into the borehole. The cage is designed based on structural requirements to provide strength and stability to the pile. The reinforcement cage should be centered in the borehole using spacers or centralizers to ensure uniform coverage of concrete around the steel. 7. Pouring concrete. Concrete is poured into the borehole either using the TREME method or direct pouring, depending on site conditions. TREME method, a pipe, TREME, is used to place concrete from the bottom of the borehole to the top. This is especially useful in the presence of water or slurry. The TREME ensures that fresh concrete displaces the slurry or water, preventing contamination. Direct pouring. If there's no water or slurry, concrete can be directly poured into the dry borehole. Concrete is poured continuously to avoid segregation and to ensure full coverage of the reinforcement cage. 8. Removing the casing or slurry. After concrete is poured, remove the temporary casing by gradually extracting it as the concrete is placed, ensuring the borehole remains filled with concrete. If slurry was used, it should be displaced by the concrete and removed during the concrete pour. The concrete should fill the borehole completely, and the top of the pile should be slightly above the final level to allow for trimming. 9. Curing and finishing. Once the concrete is poured, it must be allowed to cure. Proper curing is essential for strength development. Trim the pile head to the desired level after the concrete has hardened. This is done by cutting off excess concrete and any exposed reinforcement bars above the cutoff level. 10. Pile testing, optional. To ensure the pile meets load-bearing and safety standards, tests may be conducted such as static load testing. A static load is applied to the pile to measure its bearing capacity. Dynamic load testing. High-strain dynamic testing to assess the pile's performance under impact loads. Integrity testing. Non-destructive methods like cross-hole sonic logging, CSL, or pile integrity test, PIT, are used to check for defects such as voids or cracks. Tools and equipment. Drilling rig/auger. For boring the hole. Temporary casing, to stabilize the borehole if required. Reinforcement cage, steel bars that form the structural framework inside the pile. Treme pipe, for placing concrete in waterlogged conditions. Bentonite slurry, used to maintain borehole stability in wet conditions. Advantages of bored piles. Suitable for deep foundations in difficult soil conditions. Minimal vibration during construction, making it suitable for urban areas. Can be installed in various soil types, including soft clays, sands, and rocks. Allows for large diameters and depths, providing high load-bearing capacities. By following these steps, bored piles can be constructed safely and effectively to provide the necessary support for a wide range of structures.